All right, we're going to go ahead with the second PowerPoint. And again, you'll have more pictures if you look at the PowerPoint that is on our modules that has color in it. It's very, very hard to transfer the pictures and the color when you're doing video. At any rate, we're going to talk about the complications we did the whole span of pregnancy from antepartum all the way through delivery, including PAH and everything else that goes along with it, all the way to HELP syndrome. So now we're going to look at concurrent disorders of pregnancy. So what does that mean? It actually means that go along the continuum, and a lot of it prior to. But the concurrent disorders that we're going to look at basically are gestational diabetes and RH incompatibility. And basically, the pathophysiology of an RH problem is if mom's Rh positive, there's no problem at all. Because the Rh positive person has the Rh negative antigen on their red blood cells. So they're good. The Rh negative person does not have the Rh negative antigen or the positive antigen. So it doesn't recognize it. So when blood from a person who is Rh positive enters the bloodstream of a person who is Rh negative, the body reacts as it would to any foreign substance. It doesn't recognize it. It develops antibodies to destroy the invading antigen. To destroy the Rh antigen, which exists as part of the red blood cell, the entire red blood cell must be destroyed. And that's why we refer to it as hemolysis. It's just the breakdown of the red cell. Theoretically, I think I've said this before to you, fetal and maternal blood does not mix during pregnancy. That's what they say. But we know it does because we have these conditions that develop when we do have an Rh negative mom and an Rh positive baby. In reality, they think small placental accidents occur that allow a drop or two of fetal blood to enter the maternal circulation and initiate the production of antibodies to destroy the Rh positive blood. Sensitization can also occur during a spontaneous or elective abortion or during an antepartum procedure such as an amniocentesis. So almost any time you go in there for a procedure like any of the abortions, the blood has the chance to mix if there's a placenta there, and then we can have this problem. Again, only if we have an Rh negative mom and an Rh positive baby. If the antibodies to the Rh factor are present in the expectant mother's blood, they cross the placenta and they destroy the fetal erythrocytes. And we already said that to destroy that Rh antigen in the Rh positive fetus, it's going to destroy the entire red blood cell. So the fetus becomes deficient in red blood cells, which are needed, we know, to transport oxygen to fetal tissue. As fetal red blood cells are destroyed, fetal bilirubin levels increase, and we know that because it's on the red cell because it carries the hemoglobin. It's the heme part of that. And that leads to neurological disease or kernicterus, or you can either say kernicterus or bilirubin encephalopathy. This hemolytic process results in rapid production of erythroblasts because the baby's heart is saying, wait a minute, and it's compensating. So it's producing a ton of the red baby blasts, which are immature red blood cells, but the immature red blood cells cannot carry oxygen. So we have a big problem here. The entire syndrome is termed erythroblastosis fetalis, and it results in congestive heart failure in the infant prior to them being born. Because again, the process, when the infant is deficient in red blood cells, because the mother is killing them off, the Rh negative mom who has antibodies to the Rh positive infant, the baby's heart is going to compensate and make too many of the erythroblasts, and the baby blasts do not carry oxygen, so it's going to continue to do this, and the baby can be born with congestive heart failure. Women should have a blood test to determine their blood type and Rh factor at the initial prenatal visit. We need to know if they're Rh negative. They will go ahead at 28 weeks gestation and give them RhoGAM. And we'll talk about RhoGAM in a minute. Rh negative women should have an indirect Coombs test to determine whether they are sensitized. And sensitized mean, have they developed antibodies? So I'm going to say that again. Rh negative women should have an indirect Coombs test. And that Coombs is spelled like a comb, only it's got an extra O. It's COOM, B as in boy, S. And I'm sure that was the person that was able to define this process. So an indirect Coombs will show if the Rh negative mom has developed antibodies as a previous exposure to Rh positive blood in the serum. Maybe she had an abortion, maybe a miscarriage, maybe she had a prior amniocentesis. We don't know. But the indirect Coombs will show if the Rh negative mom has developed antibodies as a previous exposure to the Rh positive blood in the serum. A direct Coombs detects abnormal antibodies attached to the surface of the patient's red blood cells. So the direct Coombs would be done on the infant. Doesn't that make sense? Again, the direct Coombs detects abnormal antibodies attached to the surface of the patient's red blood cells, meaning, okay, we know mom's been exposed, now mom is attacking the infant's red blood cells. When we have a problem with a jaundice at birth and or I guess in congestive heart failure, they're definitely going to test the baby for direct Coombs and hope at that point they're going to figure out if mom's Rh negative and if she had not ever received RhoGAM. So in looking at this picture, you can see we've got an Rh positive baby, which is much more common than Rh negative, and we've got an Rh negative mommy. The Rh positive has the Rh antigen is present on the red cell. And on the mommy's cell, the Rh negative, no antigen is present. And so we have the Rh blood entering the bloodstream of an Rh negative person, and we talked about it. How does that happen? Usually it's some type of blood that's dripping, passed through from the placenta at one time or another. The body sees this as a foreign substance and produces antibodies to destroy what it doesn't recognize. The next pregnancy, the Rh antibodies that were all made, there's all the antibodies that are made in mommy's blood, can cross over to the Rh positive fetus and begin destroying. These are all destroyers. That's what antibodies do for us. They protect us. They don't know that they're hurting a newborn baby. And so I've got other pictures if you don't like that one. So here we have an Rh negative woman before pregnancy, and then an Rh positive fetus. We've got placental separation, and we've got maternal sensitization to the Rh positive blood in here. Maternal development of anti-Rh antibodies because it doesn't recognize it, it's foreign. The next pregnancy, the Rh positive fetus, maternal anti-Rh antibodies enter into the fetal circulation, and they antibody to fetal Rh positive red blood cells, the anti-Rh antibody of mom to fetal Rh positive red blood cells, and we have hemolysis of the fetal red blood cells. So I just said this a different way than I did over here and here. It's just looking at it a different way. And again, direct Coombs detects abnormal antibodies attached to the surface of the red blood cells, so that would be the baby. And indirect Coombs detects antibodies against red blood cells found in the patient's serum. And then as far as the ABO incompatibility goes, type O has no antigens on the red blood cell. It has both anti-A and anti-B antibodies in the plasma. I'm going to say it again. As far as the ABO incompatibility goes, type O has no antigens on the red blood cell, but it has both anti-A and anti-B antibodies in the plasma. So it has the potential to destroy type A, B, and AB blood. So most of the cases of ABO incompatibility happen with mothers who are type O that have an AB fetus or AB. Type O is the universal donor. Why? Because it has no antigens on the red blood cell. O negative, I'm sorry. I was talking about O positive up there. O negative is the universal donor because it has no antigens on the red blood cell. Type AB positive is the universal acceptor. Why? It has both AB antigens on the red blood cell because it won't produce antibodies against it to destroy it for O negative. So again, O positive has no antigens on the red blood cell, but it has both anti-A and anti-B antibodies in the plasma. So it has the potential to destroy type A, B, or AB blood. And again, most cases of ABO incompatibility happen with mothers who are type O that have an AB fetus or, A blood, B blood, or AB blood together. And type O negative is the universal donor. It has no antigens on the red cell. AB positive is the universal acceptor because it has both AB antigens on the red blood cell. I hope that makes some sense. Okay, now we're going to talk about antigen, listen to me, ROGAM. There's also another one called Rofalac that is also an immunoglobulin, just like ROGAM. It's fairly new in the last 10 years. It used to be we just had ROGAM. But anyway, ROGAM is an immune globulin. There's only one of ROGAM. And like I said, Rofalac is just like it. And Rofalac is spelled RHOPHYLAC. And both of these are immune globulin. They can be given, most of the time, ROGAM is only given IM. Rofalac, they're not telling us, can be given IM or IV. Okay, I'm going to stop right now and we'll go on to the next tape.